everybody knows that that means less than or equal to. This is a matching question where it's got, you know, each one of these and you're supposed to match it with its description. So, like that. Less than, equal to, greater than, equal to, not equal to. So, is this valid code? Assuming everything was set up correctly. What's wrong with that code? In C and C++, it would actually compile, but it certainly would not do what you hoped.
Setting x equal to 3
In the if statement, right. We have a single equal sign inside the if. Whenever you're doing comparisons, you always use the double equals. What if it had been worded like this? If x is equal to 3, semicolon. What's wrong with that? I just pointed it out.
Yeah.
It's a semicolon. But the reason why is it would treat it like this. If x is equal to 3, do nothing, and then go ahead and do this. That's how it would be treated. True, false. You can't or should not put braces around a single equals in an if or an else. Excuse me, an if or a while statement. This is bad syntax to have the braces there. True or false? And that's false. Of course, it's totally fine. They're optional, but it's actually preferred, in my opinion, to do it. So if we have this, what is B going to equal? Will B be true or false? It will be false because this is true, and that reverses the truthiness of it. I think I forgot to put this on the quiz. Maybe not. If you have this, x is equal to 100, while x is less than 10, x plus plus. Did I put a question like this? What is x equal to after this code runs? Correct.
Yeah.
Was that on the quiz? All right. But we know that while loops are pre-test, so it won't even go in here. Howsoever, if we took the same code and did this, x is equal to 100, do this, while x is less than or equal to 10, what would x equal to after it was all done? In another class, I had a question that looked something like this. If x is equal to 3, print ABC, else print DEF. And it was a short answer, and I said, oh, and up here it had x is equal to 3. And I said, what would this print? This is the first time I've ever had anybody do this. Their answer was, if x equals 3, it would print ABC. If x does not, so very thorough, does not equal 3, it would print DEF. Yeah, you can't really argue with that, but I really wanted just to see the number. So, the other thing that people like to do, and by like to do, I mean it pops up over and over, is when something looks like this. X is equal to 3, y is equal to 10, z is equal to x plus 2 times y. And then I say, what would z be? I always get somebody every semester who says, well, z would be x plus 2y. And you're going, yeah, I can't argue with that, but no. So I'm trying to make those all multiple choice now, rather than fill in the blank when it does something like that, just because. Okay, so if you know that the repeated code in a loop always has to be performed at least what time, what kind of loop do you use? A do loop, yeah. When you're writing a for statement, do you separate the goodies with semicolons? That looks like a sad elephant or something, I don't know. Or with commas? I had all sorts of wrong things. Anyways, which is correct? Yeah, you use the semicolons. And we know the order in which they are. This one is the initialization. This one is the comparison. And that's the update. So if I mix them up on you for some reason, if I did this for a plus plus, a is less than 10, and a is equal to 0, you would know that that was not the correct answer. I don't remember this being on the quiz, but how do you compare two strings? Do you do this, if S1 equals S2, or do you do if S1 dot equals S2? Only one of those is a good way of comparing strings. Pick one.
Yeah, I think it's B.
It's B. And the reason for that is this just compares where they're pointing. So, yes, if S1 and S2 are pointing to the same place in memory, they will be the same. But they could be pointing at different places in memory and still have the same contents. You have two different people named Jeff, and so you're still trying to check it. But that's just for strings, you know, or other objects. Objects, references, class variables, whatever, should be compared with dot equals. And when we get to hardcore into writing our own classes, you would be adding dot equals methods to your own classes so that you can do the same thing. In the language C++, you can modify the behavior of equal for your class. And so in C++, you can actually get away with comparing strings like that. That's the difference between Java and C++. C++ has a little bit more flexibility in how you design your classes, and if you feel like making the plus sign do something weird or equal do something weird when it's dealing with your class, you can override all those. I'm skipping the ones that are already very, very similar to our quiz questions. All right, what do you call it if you have something that looks like this? For a is equal to 0, a is less than 10, a plus plus. Then you have another loop inside it. What's that called? That's a nested loop. And here's a little thought question. How many times would it print hello? Is it going to print it 20 times or 100 times? It's going to print it 100 because this inner loop repeats 10 times for each one time that this goes, and this one also repeats
Oh.
10.
Okay.
So, what if you did something crazy in that second loop and changed the value of A? Would it break out of the whole thing?
You can monkey with A all you want, and it still won't break out until you make it not less than 10.
Okay. Well, I mean, I guess if you set it to 15.
Right, if you set it to 15, then it would break
then it
out.
would just break out.
Yeah, at when it was done with the body. Like if I did this. This is slightly convoluted. Like that. When we set A equals to 15, is it going to immediately leap out of the loop? No, it's not a break statement or anything like that. It still has to finish completion of the inner loop before it would exit out.
I can't imagine why you would want to do this.
Well, sometimes you may need to monkey with these values in here. And you can leave any portion of a loop declared or off. You could do that and just leave it up to the loop itself to monkey with that value of A is equal to 15. But in that case, you just should have worded it as a while loop. All right, this wasn't on the quiz either, but take note of it. There's a class that is included by default, or imported by default in every Java program. So we have been doing the add import, and we always did import java.util.scanner. That kind of implies that java.util is not the one class that is included by default. The one that is, and math is as well, which puzzles me, is the reason why the book makes a big deal out of this. Java.lang contains a bunch of stuff like the string class. Java.util is not included by default. Java.lang is. I could conceivably just remove this question. It also was not covered on any of the quizzes. But if I wanted to get the maximum value of an integer, how would I get that? I would use a wrapper class and get integer.maxValue. Same for if it's a double. If I want to find out the largest value a double can hold, or a float, you use double.maxValue. Why would you care? Well, you may have a value stored in a long and you want to see if it's too short or too large to fit. You know, so if you have long L is equal to 93 trillion, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 93 billion, that's too long to fit into an int. So if you did this, if long is greater than integer dot max value, it would tell you whether or not you could fit that in. You know, print error, else go ahead and store it in your int. Something like that. Yes, you could just cast it, but if you cast it, you wouldn't know. There is also a function, I think it's in the math class. No, I can't tell you where it is. Never mind. I know that there's another way of doing this that will generate an exception. It'll cause an error if you try to do a cast and it won't fit. But I'm kind of spacing out here. Anyways, max value. Max value is how you get the largest value. That also implies that there's a min value if you want to find out the smallest number. I think I'm going to delete that question. What do you call a class that gives extra functionality for a primitive data type, like integer or double or something like that? Yeah, it's a wrapper class. I just already kind of gave y'all the answer back up here. Or I deleted it after I typed it, but yeah. So in the wrapper class, and yeah, the wrapper class gives you extra functionality. The ability to parse double, that kind of thing. I think I'm going to dump that one as well. How do you get the length of a string? How would I put the length of string named s into a variable named x? X is equal to what?
Index of?
We're actually doing length, so s dot length.
Yeah.
Yeah. And you Python programmers need to note that that's different than it was in Python where you did this. And that's also true in C++. C++ has a length function. Java does not have a length function. You have to call the method that's part of the class. So that's bad. Don't do that. In fact, I'm going to delete it. There we go. Okay, when you're dealing with substring, string y is equal to hello Java, and you do this. A is equal to y dot substring 1 comma 4, and then you do b is equal to y dot substring 4 with no second number. What does A wind up being? Well, what does this mean? How long is this string going to be? It's going to be 3, so starting at character 1, there it is, going to be ELL. What about the second one? Since we left off a stopping point, what does it do? It runs to the end of the string. So starting at character 4 and going all the way to the end, 0, 1, 2, 3, 4. So it would be O Java. You know how to use the absolute value function. If I have a variable called a and I want to put the absolute value of a into b, what does that look like?
ABS.
Yeah. So the syntax will be b equals abs a.
That's it.
Yeah. And again, that one's going to go away.
Do you have to call the math class for that?
Yes, you do. My mistake. I would have given myself only half credit or less. There we go. Math.abs. So that's our exam. I'll open it Saturday morning, and y'all can have the best weekend of your lives working on it. It's not going to be any harder than the first one, though, so you'll get it done in, an hour or two. Don't know if anybody's missing one of these, but I see one left up here. Alrighty. I really don't like saving the this. I don't think I'm going to. We did cover it on video, so if you want to review it, you could watch the video. Anybody gonna yell at me if I delete it?
No.
Nope, I don't think so. Paris is too shy to yell, though. You could just glare. Okay, guys. So if I correctly recall, what we did Tuesday. Oh, I'm on the wrong. Oh, no. Why am I spacing out? This does not. Did we lecture on arrays on Tuesday? Okay, then I'm getting all confused with another class. That would explain my confusion at this point. All right, so we're going to be talking about object-oriented programming. And to some extent, we've already been doing object-oriented programming because we have been using objects. We've used the scanner class and we've used the string class. But beyond that, we haven't done a lot. Have we created a rectangle class? Yeah, so we have done some. So an object, or I should say a class. I wish I could rewrite this slide, and actually I can't. But a class is a set of data and a set of behaviors, that's what this book calls it. I would call it methods, because that's what Java calls it, that modifies that data. So in a class, you have data, and then you have methods that act upon that data. So for example, the string class. The string class contains a sequence of characters. And then you have methods. Like you can get the length of the string class. Or get the length of the string. Or you can use .char to pull out a specific character. Or you can use index_up to search it. Those are all methods that act upon the data. And the current values of the data in the class is known as the state. So if you have a string and it's got the word Joe in it, capital J-O-E, that's the state of that object. And so sometimes you talk about maintaining the state of the object. That just means that you might write it out to a file before the program closes, and then the next time the program loads back up, it loads it back in, and then that string still contains the word Joe in it. We're not doing file I/O, but that's the state of the object. Or if you have a point class with an x, y, and a z values, then if x was equal to 10, y was equal to 4, and z was equal to 3, that's the state of that specific object. So supposedly, The benefits of object-oriented programming is that programs are more understandable. Now, if you give this language to somebody who's been doing Fortran or COBOL or some other non-object-oriented programming at all, then they're going to start to argue about whether being, quote, more understandable. But since people tend to think about problems in terms of objects, it's easier for them to understand a program that is split into objects. Meaning that if you present them code and you say, okay, here is my, my fighter object, and here is my building object, and here's the dot draw method on that fighter object that's going to draw my fighter on the screen, and here's the dot draw method on my building object that's going to draw the building. Then people understand, oh, I see how to use it, that kind of stuff. So people think about problems in terms of objects, whether they think about it or not. So since an object is just a cluster of data, an employee has a cluster of data. Their first name, their last name, their social security number, their pay rate, and all that kind of stuff. The attachment of methods to that data does not make as much sense when you're dealing with an abstract thing like employee until you get the concept. But then you think, okay, hire. I'm going to hire this person. I'm going to give this person new insurance. I am going to terminate this person. That kind of thing. I'm going to calculate their salary. Those would all be methods that would act upon that data. And so, supposedly, fewer errors. Since objects provide encapsulation for the data, it's harder for the data to get messed up. If you have an employee object, and your company has a rule that says that employee names cannot contain special symbols like $signs, then when you call set name, the set name method can actively validate whether that is good data or not. And that could stop your program from malfunctioning later if it found some data that it wasn't expecting, because you're not the only programmer who's working on a project, at a company most likely. So you will have several people who will be, trying to figure out how to put data into these things. And if you write your objects well, if you write your classes well to validate the data as it's being set, then you can prevent errors down the line. An error condition might be, they forgot to enter a last name, or they entered a completely invalid birth date, like June 32nd, that kind of thing. And then they were supposed to calculate something based on that data. It can't. But if you can tell, the person typing in the data right away, that's invalid data, then you're not storing anything. You're not writing out to disk anything that's wrong that could later be processed and cause problems. And that idea is called encapsulation. Just like you have a capsule that's medicine and it's wrapped in a shell. So here we are wrapping our data in a shell, and it's only through our methods that we allow the user or another programmer to go in and modify it. Another example would be is if you're writing a payroll program and somebody thinks that they're going to go in and sneak into the code something that if name equals Jeff, increase salary. Well, if the set salary method has some kind of authentication in it to make sure that you're an administrator, that you have the rights to be looking at that, then the program could not be written to do that if the person running it did not have that access. So that's another form of validation. Just make sure that the data doesn't get messed up by only using the methods that's provided. And that's what's known as the interface. You're giving an interface to a set of data. And if they can only manipulate that data through your interface, you're much better off than if they can reach in and directly start changing values. And when I say they, I mean another programmer, or even yourself. So a class is a description. A class is a blueprint. You buy a book of blueprints and you pick which house you're going to build. That's not your house, it's just a blueprint. Well, that's the class. Later on, you will make some objects from that class using the new keyword. That's like building a house. Then you actually have objects. So the class will include a list of variables and a list of methods. there is the idea of class variables and instance variables, or class methods and instance methods. And I'll give you an example. When we were using the scanner, in order to use the scanner, we had to do something like this. We had to create it, and then we could use it. Int I is equal to sc.nextInt. We had to have an instance of the class in order to call nextInt. If we didn't have an instance of it, we wouldn't be able to invoke it. This is what we could not do. We could not go I is equal to scanner.nextInt. Why? Because it doesn't know what it's scanning. There are different kinds of scanners. There are scanners that read in stuff from the internet. There are scanners that read in from file data. The scanner system.in reads in from the keyboard. But there are multiple kinds. So without a specific instance of the scanner, this won't work. So this is not a class method. It is an instance method. We had to have an instance, and an instance is an object that was created with the new keyword. So this is an instance method because when we invoked it, we used an object in front of it rather than the name of the class. This would not work because nextInt is an instance method. Opposite of the instance method are the class methods. With a class method, you don't need an instance. The example, math.abs. Here's what we do not do. We do not do math, my math is equal to new math, and then x is or I is equal to the my math dot absolute value of -3. We don't do that. We don't need a math object in order to use absolute value or POW or anything like that. How do we use a math class? We don't do all this rigmarole. We just do this. I is equal to math.abs. So we are prefacing the name of the method not with an instance, but with the name of the class itself. You don't have to create an instance of that class before you start using the math class's methods. So this is a class method, not an instance method. This means that behind the scenes, ABS was declared as a static method. And behind the scenes, nextInt is not declared with the static keyword. That is how Java differentiates between whether something is a class method or an instance method. And why is that important to us? Because we need to know how to invoke it. If it's a class method, you preface it with the name of a class. What's the easiest way to determine if what you're looking at is a class name or not? Just look at the first letter. And if we all follow our golden rules, then the first letter, if it's capital, it's a class. And so it's a class method. Now, if we cheat and make variables that have uppercase letters beginning them, then we can't use that rule of thumb. But SC is an instance. So nextInt is an instance method. Math is a class, so math.abs is a class method. That means this was declared static, and this was not declared static. So why is main in our stuff declared static? Public static void main. That's so that Java knows how to invoke it without having to create an object first. All it has to do is find the address of the main method and tell it to start executing, and it runs it without doing any rigmarole about creating an object first. If it was not static, then the Java runtime engine, the virtual machine, would actually have to create an object before it could even call the main method. And the same is true for variables as well as methods. Math.pi, that means that pi was declared as a static variable. That makes it a class variable rather than an instance variable. Instance variables are things that change on an object-by-object basis. We have two television sets. One's got a 27-inch screen and one's got a 30-inch screen. That variable, screen size, is an instance variable because it would change depending upon which TV you had. And it's always kind of hard to come up with a reason to even have static methods in a beginning programming class. But we'll come up with one. We're going to make our class called mouse. Mouse has two bits of data. One is the weight of the mouse, which just starts off at 1 gram as a baby mouse. And then it's got an int for age. Starts off as 0 days old. And then it's going to have some methods, like a method called age a day. And age a day will increase the age. It will increase the weight by a certain growth percentage. So public void age my mouse. What that does is when we call age my mouse, it increases the age by 1. It increases the weight by a certain percentage, which I'm going to call growth rate. Then we would probably add a get age and a get weight. But anyways, we don't have growth rate defined here yet. So the natural thing to do would be to come up here and create a variable for that as well. Double growth rate. The question could be, might not occur to us, but I will ask it, is the growth rate the same for every mouse? If the growth rate was the same for every mouse, then we would preface it with the word static. It would be a static. It would be a class variable. Every mouse would share the same growth rate. Now, it's more likely that different mice are going to grow at different rates, and so it needs to be an instance variable. All three of these things, we're going to say that mice grow at 5%, so the growth rate is 1.05. Each one of those is an instance variable, so when we create a new mouse, we can set those values. M1's growth rate is equal to 1.10. He grows faster than the other ones. M1's dot weight, he was born big. He weighs 2 grams. M1's age, well, we didn't actually get him when he was first born. He was actually 10 days old already. There. We have set all of those things. These are instance variables because if we made a different mouse, we could have different values. This mouse is a little bit tinier. So M2 dot growth rate, he only increases 1% a day. And he was scrawny, so his weight was 0.5 grams. And we got him right as he was born, so his age is 0 days old.
They're supposed to be in 2.
Pardon me?
Those last 2.
Yes, you're right. These are supposed to be 2. There we go. These values differed on an object-by-object basis. That makes them instance variables. We could conceivably, well, that's enough. I'm not going to even go into that any more than that. If you had data that you wanted to apply to every mouse, not just one of them, then you would make that a static variable. And it's always difficult for me to come up with a good reason for doing that. To describe classes, people use what's known as UML, Unified Modeling Language. And the idea of Unified Modeling Language is a lot more complex than what we see here. But this is the basis for describing a class. You get a box. It's got 3 sections. The top section is just the name of the class. The middle section, ooh, we're going to throw another fancy word at it, attributes. Okay, these are just the variables. Every book has to come up with its own term for it, seems like. In C#, these are always called fields. They're still variables. earlier, this very text was calling them behaviors, but ooh, all of a sudden it's changed the word behavior to operations. Just remember, class name, variables, methods. So our mouse class would have 3 variables: age, weight, and % growth rate. And then it would need 3 methods. One that sets the growth rate, one that grows it, I call that age, and then one that displays the contents of the mouse. Why would we want a set % growth rate? Because when this was created, although it doesn't show it in the UML like it should, the designer of the class probably said, oh, I want that data to be private. I don't want anybody to be able to reach into it and change those values. The only thing that can change the values of age or weight or % growth rate are the methods themselves. So some bad programmer couldn't go in and arbitrarily set the age to 1,000,000. The only way age is going to increase is each time we call a grow method. Same for weight. Nothing could arbitrarily go in. In real life, we would actually want a lab technician to be able to, weigh the guy and then type the weight in. But then in that case, we would add a set weight method. So that is a key thing to remember when designing classes. This will be about the last thing we do, is talk about the principles for designing classes. Rules of thumb. And we're going to be adding to these until we have about 5 of them. But the first 2. The first rule of classes is there is no classes. No, I'm kidding. First rule of classes: data, private, members, public. If these variables, growth rate, weight, and age, had been set to private, then my code down here in main, wherever this was, would not be able to set those values. Each one of these each one of these lines would be an error if they were declared as private. Since I left them off, it defaults to something pretty close to being public. I forget exactly what the keyword is, but it means public to everything in the same package. The word public itself means absolutely anything can access it. But the default for Java is not quite public, but it's public for every piece of code that's in the same package. So by removing the word there, private, or by adding the word public to my class, I've said that it's okay for the client code to go in and change those values directly. That kind of violates the first rule of classes, which is to make your data private and your members public. That's what's encapsulation. And the reason you do that is so that you can encapsulate your data, you can protect it by validating the calls. The data only gets changed in the ways that your program dictates as being acceptable. Nothing can go in and set a mouse to have a negative age or a weight of 10 billion or something like that, if that data is private and you have written your methods carefully enough to forbid stuff like that. Okay. We will be tacking on more rules for classes, but those are the first 2. Nope, it's not October anymore. Alright guys, that's it. Look for the exam to open up Saturday morning. If you get stuck on it, feel free to text me a question.